Welcome friends. Now we will be drawing this part. We will be making up this part in SolidWorks 2015. To make this part we will have to make it up in two steps. Number one, we will be making this base plate, then we will be making this projection. To make this plate, first of all, I want to tell you, whenever we want to make any part, we should see in which side, in which view, which side has been shown. So this is the top view of this part, and the base plate has been perfectly seen in the top view. So we will be drawing the base plate in the top view. So now the dimensions of the top of the base plate is 220 mm multiplied by 340 mm. So we'll be picking up a sketch in top plane, and we will be putting a rectangle for this base plate. Now there are five kinds of rectangles. Number one is the corner rectangle, in which we pick up one corner and then the opposite corner of this rectangle, and the rectangle is generated. Next kind of rectangle is center rectangle. This is operated by the center of this rectangle. We will be clicking for its center and then spanning it out. We can generate the rectangle. Then third rectangle is 3-point center corner rectangle. These two rectangles already discussed can be used when the rectangles are parallel to x-axis or say y-axis. But if the rectangle is not parallel to x-axis or y-axis, we do use the third kind of rectangle, 3-point rectangle. We will be clicking at one point, then we will be defining the inclination of this rectangle, and then we will be spanning it out to create the rectangle. This is our 3-point rectangle. Next is our 3-point center rectangle. This is somewhat similar to the center rectangle. We will be first clicking out the center of this rectangle, then we will be defining the inclination, and then we will be spanning out to generate the rectangle. This is our fourth rectangle. Now fifth one is a parallelogram. In this case we will be first clicking the first point, then showing the inclination of the base of the rectangle, and then the inclination of the adjacent side of the rectangle. So the parallelogram is generated. So anyhow, in this case we do need a center rectangle. As I have already told you, for the symmetrical bodies, symmetrical shapes, we do use centralized sketches. We start the sketch from the center. We keep the center of the whole geometry to the origin of this plane. So I am clicking here to start the center from to start the center from the origin. I have generated the circle, the rectangle. I will be putting up the dimensions of this rectangle. The horizontal side is 220 mm, and the vertical side is 340 mm. This is our horizontal side, 220 mm. This is our vertical side, 320 mm. This one is over. Now next we can see in this rectangle is the rounding of the corners, which we call as a chamfer, fillet. If we put a flat cut over here, then we call it as chamfer, and if we round it up, then we call it as a fillet. So this one is a fillet. I will be showing you how we can apply the fillet. This is the fillet. Here there are two commands. One is fillet, sketch fillet, and second is the sketch chamfer. So I will be using a sketch fillet here. The radius of this fillet will be, as we can see from here, 25 radius. So I will be putting here 25, and I have to just click on this point where these two lines are meeting, and the chamfer is created. Same way I can do it for here, and for here. Clicking OK, the chamfer is generated, and I will be closing this application, this command. This one is the first command. Now I will be showing you the second command, the chamfer command. The chamfer command, we can do it by two ways. Either distance means equal distance, either equal distance or unequal distance. If we want to put the equal distances, suppose it was 25 So clicking here, on both sides a cut of 25 is generated. So a chamfer is generated which is at a 45 degree from this angle, this side, this line I will be showing you. This one is 45 degree. Now I will be showing you other options in this chamfer. This one was the equal distance. Now I am making them different. The first one is 25 and the second one I am taking as 15 So now as soon as I am clicking here, the distance at 1 is 25 the horizontal distance is 25 and the vertical distance is 15 This one is the second way. And now there is another third way, angle distance. I am giving the distance, one second, I will be redoing it. I am giving angle and distance. The distance is 25 and the angle is 45 for the sake of showing you something different, I will be changing the angle by into 65 degree. So clicking here, this is a 65 degree angle from this line, from the x-axis. So you can see the difference between all of these. It best depends upon which dimension, which information you do have about the chamfer. According to that, you can apply that kind of chamfer. So anyhow, I was actually going to apply the fillets here, 25 fillets. This one, and suppose I want to put these two fillets of 25 radius and the last two as 20 radius. So I will be just clicking it as OK, and then I will be proceeding for the next two. Before that, I will be changing the radius at 20 So here, this one, clicking this one, clicking here, the radius here is 20 But naturally I do have to make all the radiuses as same, radii as same. So I will be retaking the chamfer command, the fillet command, and making it as 25 This one, and then this one. Clicking OK, and then closing the command. This one has been done. the sketch for the base plate has been generated. So now as we can see, the thickness of this base plate is you can take it from here, it is 12 mm. So we will be extruding it 12 mm. And clicking OK, the part is complete. This way we can generate a part. Similarly, we will pick up the one of the faces on which we have to generate the projection. I have taken a new sketch, and now as I can see on the top, the dimensions of this projection is 65 mm wide and 200 mm long. So I'll be making a projection, making a base sketch for the projection. I have taken the center rectangle. Here you can see the middle, the origin is at the middle of this previous rectangle. So I can easily pick up, I can easily put up the next triangle very easily, because I have already put the previous triangle on the origin with its center on the origin. Now I will be taking its dimensions. It was 200 mm and 65 mm. This one was 200 mm and this one 65 mm. Now the radius is 10 mm, the fillet radius. So I will be applying the fillet of 10 mm. This one, and this one. It's finished. Next thing I have to apply is there are two holes, and you can see the holes are throughout the projection, not through the base plate. So in the SolidWorks, actually we have to the software actually considers the area, the closed area, by any diagram, by a loop. For example, I will have to see you. This is a closed area by a loop. If I generate another area within this area, the feature will skip that area and pick up all else area. I'll show you. The distance of these holes are 37.5 mm away from this line, this side, and okay. So I will be taking a midpoint line. I will provide the center here, and this is my midpoint line. Now I can very easily put up its dimensions. It was 125. Let me show you. This one was 125. The distance between these two, and the holes are at an equal distance from the center. From this point, this distance and this distance is same. So this one will be already automatically 37.5 mm. Now the next thing I want to show you, I have to make this line as a reference, as a construction line. I have clicked over it, and you can see windows popped up here, and here I can put it up as for construction, and I will make it okay. Now you can see it has been converted into a center line. So the feature will not consider this line. Now I'll have to put up the holes here, a circle here, which will be used as a hole, a circle here. Next, now I'll have to apply the smart dimension. So I have to see the radius of this hole. It is 15 mm in diameter. Clicking here on the circle, I have to click on the profile of the circle, and the dimension is generated, so I can edit the dimension. It is 15 mm, and same is here, 15 mm. Now the profile is complete, the sketch is complete, and now we have to extrude it up. So now you can see the extrude command has picked up all the area, but have skipped that area which has been inside this area. This is the feature of this command. It will leave an area within an area. So the projection height of the projection is as we can see, it is 67 mm in total. Then deducting 12 mm from it, it will be 55 mm. So it's 55 mm. So now here the model is complete. Thanks for watching.